Good morning, guys. So today we are going to be looking at chapter 7, which is applications of uh, trigonometry. So for this chapter, applications of Trigo, most of your learning has already been done in your chapter 6. So there's going to be very minimal learning, but it's more of applying what you have learned so far. Okay, so with that being said, let's get started. Our three learning objectives for today are the first one is you need to be familiar with your angles of elevation and depression by the end of this lesson. And then the second one is you need to know what bearings are. And bearings are essentially, your compass bearing. Yeah, so it's a similar concept. And the third and most important part is your 3D application problem. So these are the types of questions that you're most probably going to see during your exam or test. Okay, so let's get started. So firstly, what is angle of elevation? So let's say you have a man standing at point A and he's looking at the wall, the top of the wall, which is your point B. Okay? So this horizontal plane and this line of sight, the angle that forms in between is called the angle of elevation. Okay? And similarly, from the line of sight and the horizontal plane, so like let's say if he's looking at the bottom of the wall, which is your point C. So the horizontal plane and the angle it makes with the line of sight is known as the angle of depression. Okay? So these are two simple concepts for your first learning objective. Okay, so let's say I give you another question. Let's say you have a man standing here, and then he's looking at this man. Okay, so just assume that his eyes are over here. Okay, his eyes are over here. So let's say if he's looking at this man, what is the angle of depression from this point for man at point B? So you have two options. Is it going to be this angle, angle of depression, or is it going to be this angle, one or two? So, what is your option? Okay, so if you chose option one, you are correct. Okay. Remember what I said earlier? Your angle has to be between with your line of sight. So this is the line of sight. So this is your line of sight and the horizontal plane. Okay. So this is the angle. And your option two is wrong because this is your vertical plane. So it is not your horizontal plane, hence it is the wrong answer. Okay, so these are two simple concepts, so just be familiar with what these terms are. Okay, now let's get started. So your first question. Um, yeah, before I go through the answer, just pause the video and try it out yourself. I think you should be able to do it. Okay, so you're given that uh you have someone um from the top of the Ferris wheel, the Singapore Flyer, from this point looking at a sports car which is point C. And then the first part is asking for the distance of the sports car from point B, which is on ground level, and uh directly below ground point A. Okay. So in this case, if you see this forms a right angle triangle. So as always, your first step should be drawing out the triangle. Okay, let me make this smaller. I hope you can still see the question. So yeah. So your first step should always be drawing out the triangle. So in this case, you have a right angle triangle. This is point C, point B, and point A. So you're told to find BC. So what information do we have here? We know that this angle is 25 degrees. And if you use your alternate angles, because these are both horizontal plane, right? So in this case, alternate angle, your this angle should be the same as this angle. So you know this angle is 25 degrees. And you're also given that the diameter of the wheel is 150 meters, but to the highest point of the wheel is about 165 meters. So in this case, which one should you use? Okay, so if you said 165, you are correct because you are actually from the highest point of the wheel. You're not looking at the diameter. Okay. So once we have this, you should be able to do your Trigo. So tangent 25 equals to 165 over BC. Therefore, BC equals to 165 over tangent 25. Okay, and then you'll get your final answer. So your answer is 353.84. Approximate to 3SF, you should get 354 meters. Okay, so that's your part one. So now let's take a look at part two. So part two is asking for the angle of depression of the sports car from the center of the wheel. Okay, so they're asking from point W. So if you draw a straight line, they're asking for this triangle. Okay, so again, your point W is directly above point B. So it will also form a right angle triangle. So first step, as always, draw your triangle. It makes it easier for you to visualize. Okay. So once you have drawn this, uh, in this case, what do we know? We have already found CB from your previous part, 353.84. And then, do we know the angle? Nope, we don't know the angle. You're actually told to find the angle. And then, oh, we know WB. Okay. So in this case, you're given that this whole length, the diameter is 150, but from the highest point, it is 165. That means the bottom part, this part here is actually 165 minus 150, 15 meters. Okay. And the center of the wheel, so from this part to this part, it should be 75 meters, which is half of 150 meters. Okay. So once we have this, your WB is just 75 plus 15. So that is 90 meters. Okay, so you're told to find the angle of depression. So if I draw this, you're asked to find this angle here. Okay. Um, so how are you gonna find this angle? So again, if you use alternate angles, your this angle should be equals to this angle. So what you're trying to find is this angle. So again, use tangent. Tangent theta 2 equals to 90 over 353.84. Therefore, theta, and your answer should be 14.3 degrees, 3SF. Okay, so this is how you do a question regarding angle of depression and elevation. If you have any questions at this point, do let me know. Okay, so now we are going to look at the second concept, which is bearings. Okay, so bearings is essentially a very vital concept, especially if you are a guy during army, you would learn what bearings is over there as well. But other than that, it is a simple concept which we are going to look at now. Okay, so whenever you look at bearings, right? So you have your north, south, east, west, which is your poles of your compass. And whenever you look at bearings, you always look with respect to your north pole. Okay? Your north pole. So in this case, if I ask what is the bearings of O, point O from D, then you should basically draw a north pole here. And your bearings is basically this part, this whole angle. And how are you going to find the value of that angle? It is basically, if you draw this, so this is 90 degrees. You know this is 90, and you can find this because this is given 35. So if you use your calculator, 180 minus 90 minus 35, you'll get 55 degrees. So your answer should be 145 degrees. Okay? So always, for this part, always take note of the language. So whenever they say from something, then you should be looking from that point. So that is where you uh draw your north pole. Okay. So if I ask what is the bearings of D from O, so in this case, so if I ask you what is your, okay, let me write it down. So if I ask you what's the bearing of D from point O, so at you should draw your north pole at point O, which is already drawn. So it is basically, and it always goes clockwise, by the way. So it's basically, oh no, it's basically this point, okay? So this is basically 360 degrees because one full round gives a 360 degrees minus 35 degrees. And your answer is 325 degrees. Okay? So yeah. Okay, so I wanted to calculate. Okay, let me write down a few questions. Okay, I wanted to find the bearing of O from point A, B, and E. So I'll just do one example. So if I ask for bearing of O from point A, then again just draw your north pole here. So it's basically this whole angle. And how are you going to find that? If you hyperextend this, you can find out this angle, which will be 20 degrees. And then this is 90 degrees. So it's just 360 minus 20 minus 90. 360 minus 20 minus 90. Should get 110, 250 degrees. Okay. Okay, so now I want you to do that for point B and E. And also your part two, sorry, your part B from point O. So the only difference is now your starting point is from point O. So okay, again I'll do another example. So from point O, find the bearing of A. Okay. So again, draw a north pole here. So from point O, A is 70 degrees. It's already given. Okay. Okay, so that is your bearings concept. Now let's look at a problem involving bearings. Okay. Okay, so you're given that a boat sailed from point P to island Q and the distance is 20 degrees. And you're also given that on a bearing of 150 degrees. Okay, so this whole angle is 150 degrees. It then sailed 30 degrees on a bearing of 50 degrees to the lighthouse. Okay. Sorry, 30 kilometers on a bearing of 50 degrees. Then you're told to find the distance between the distance and the bearing of the lighthouse from P. So this is the lighthouse. Okay, so you're basically asked to find QR. Sorry, PR. PR distance and bearings. Okay, so do you have any idea how to do this? So if you know, do pause the video and try it out. Otherwise, I'll be going through now. So before we carry on, if you see, this question actually involves your concepts which you learned earlier, which is your sine and cosine rule. So you need to be very familiar with these concepts. So now let's get started. Uh, you're asked to find the bearings of lighthouse from point P. So if you draw it out, it's essentially this angle here, which we do not know. Okay. So how are we gonna solve this? It may look like 90 degrees, but it's not, okay? So you need to calculate it. So, okay, wait, give me a second. Okay, so your first step for this type of question is always to write down whatever information you have. So in this case, you know that this is 150 degrees. So you need to find out what this angle is. So your north pole is this line is a straight line, so it's just 180 minus 150. So you get 30 degrees. Okay. Then if you look at this north pole to this north pole, they're actually parallel lines, okay? These two are parallel. So given that they are parallel, you can use alternate angles to find out what this is. Okay. So now you have the angle for one side of your triangle. And does this look familiar? It's so you're given, you need to find your opposite side. You need to find your opposite side. You know the you know the angle for your opposite side, which is 80 degrees, and you know the two corresponding sides. So with that being known, you can actually use your cosine rule. Okay. So if you use your cosine rule, your PR square equals to 20 square plus 30 square minus 2 times 20 times 30 cos 80. Okay. So again, just solve this. You should get PR equals to 33.02. 33.040. Okay. Estimated 33.0. Okay, so now you know your value of PR, and then your next step is to find your bearings. So again, do you have any idea how to find the bearings? So this time you need to use your sine rule. So sine, because if you want to find your this bearing, you need to know your this angle. So sine 80 over 33.040 equals to your sine theta 1 over 30, your opposite side. Okay. So in this case, if you calculate your theta 1, so if you type this in your calculator, you should get 63.4 degrees, 3SF. So you get theta 1 is equals to 63.4. So therefore your bearing is just 150 minus 63.4. Bearing of R from P. Should get close to 86.6 degrees, 3SF. Okay, so this should be your final answer. I hope you understand the concept so far. Okay, so now let's look at another question. So again, do pause the video and try it out yourself before I go through the answer. Okay, so now let's take a look at it. So similarly, you're given a very similar diagram, and then you're told to find AC. Okay, so what do we know so far? We know we can use alternate angles and find out this angle. So at this angle plus 120 should give you 180. So that means this is 60 degrees. Okay. Um, so once we have this, we can also find this angle. So that is just 360 minus 60 minus 238. And you should get 62 degrees. Okay, so you're told to find AC. So again, first step is your cosine rule. AC square equals to 35 square plus 55 square. And then I want you to solve this. So once we have that, your part two, the bearing of town C from town A. So they want, so from town A, so you draw a north here. So they want you to find this angle. So to find that angle, you already know this. You need to find out this angle, theta 2. So given that we have AC, you can actually use your sine rule. So sine 62 over AC equals to sine theta 2 over 55. And then you solve for theta 2. This should be your answer. And your final answer bearing of C from A equals to theta 2 plus 120 degrees. And then you'll get your answer. Okay? So I hope you understand so far. Um, Now we'll be moving on to the third concept. So again, this is very similar to what you have done so far, just that now it's going to be in a three-dimensional shape. So yeah. And then just take note that whenever it's three-dimensional, it's mostly going to be right angle triangles. So you can always use Pythagoras theorem or your Trigo first before moving on to your sine or cosine rule. Okay. So always remember the order. You should use your Pythagoras, then Trigo. After that, if these two doesn't work, so once you find out there's not right angle triangle, then only use sine or cosine. Okay, so let's take a look at this question. I'm not going to read through you. You can read through yourself, but I'll move on to the question straight away. So your first part, they're asking you to find angle BAC. So this angle. So in this case, you know it's a right angle triangle because the base is a ABCD. It's a vertical face. It's a horizontal base. Okay. So you have a right angle triangle. So again, always draw it out. B. So this is right angle. And you're given that BC is 24 and DC is 15. And you're asked to find PAC, this angle. So again, should be simple trigo. And then you just need to solve this. Okay, now your next part. They ask you to find AQC. So again, always draw it out, especially for your problem solving questions. It makes it much easier for you. So in this case, since Q is vertically above point C, this is also a right angle triangle. You're given that this is 8 cm. Um, so you need to find out AC first. So you have already you can use your part A to find out what AC is. So it's just Pythagoras theorem. So AC equals to square root of 24 square plus 15 square. We get 28.302. Okay. So once you have these two details, you can find your angle AQC. Again, just use tangent. So angle AQC equals to tangent inverse opposite 28.302 over 8. Okay, then you'll get your final answer. And lastly, um, you're asked to find CDQ. CDQ, where's that? Oh, CDQ, okay. So angle CDQ should be even easier because you already know all the sides. So again, draw it out. So C 15.8 CDQ. You're asked to find this angle. So I'm not going to be going through this part and just use your Trigo to find out. Okay. So it should be tangent as well. Okay, so this is your introduction to three-dimensional questions. The only difference is now previously it was all 2D, like it's all flat, but now it's uh pointing out. Okay. So try to imagine it as a figure. Okay, so now let's look at two more questions. Okay. So again, pause the video and try it out yourself before I start going through. So you have point A, B, C, which are on level ground. So this is a very important thing to take note of. And B is due to south of A. The bearing of C from B is 32 degrees. Okay. And CAB is 105 degrees. Okay, so blah blah blah. They ask you to find the distance between BC. So you are given all these angles. So it's not a right angle triangle, so you can't use Pythagoras or Trigo. You got to use either sine or cosine rule. So you're given two angles and one side, so you should be able to use your sine rule. It's easier. So you can find angle ACB, 180 minus 105 minus 32. Okay. So this is 43 degrees. So once you find that out, you can use your sine rule. So just give me a moment, my pen is not working. Okay, so once you have that, you can use your sine rule to find out what BC is, okay? So sine, if you want, you can draw the triangle, but I'm just going to use the one on the diagram. So sine 43 over 120 equals to sine 105 over BC. So if you make BC your subject, you'll get BC equals to, okay, and then you'll get your answer to be, your answer would be 169.96 meters. So approximate 170 meter for 3SF. Okay, so that's your distance calculated. Then after that, you're given that you have a vertical mast CT of height 25 meters, which stands at C. So this is where your 3D portion comes in. So find the angle of elevation of T from point B. Okay, so again, it may seem hard, but always once you draw it out, this question becomes very easy for you. So first step, always draw it out. Okay, so let's draw it out. So you're given that point T is vertically on top of point C. And then you're asked to find the angle of elevation of T from point B. Okay. So always draw this out. And then you're given that this is 25 meters. And then write down what other information you know. So do we know CB? Oh yeah, we do know BC. It is 169.96 meters. So they're asking for angle of elevation of T from point B. Okay. So if you draw, oh sorry, angle of elevation. So angle of elevation is this angle. Remember, the angle it forms is the horizontal plane. So once you have drawn this, it's quite simple. It's a right angle triangle, so you can use your simple trigo. Tangent theta equals to, okay, I will leave this to you to solve it yourself. So now let's move on to the last question for today. So yeah. Okay, I would say the challenge comes in when they don't give you any diagram. So you have to be able to draw everything out yourself without uh without the diagram given to you. So let's take a look at this question. So Priya is in a cable car P at a height of 80 meters above the ground. So always draw it out as you read. So you have the ground. So point P. So this is 80 meters. Okay. She observed a statue at A and a fountain at B. Given that the angle of depression of the statue and the fountain is 35 and 40 degrees respectively, uh, find the APB. Find the distance between A and B. Okay. So you have A angle of depression. So if your angle of depression is more, then your B should be further. Okay. A- Sorry, if your angle of depression is less, then it should be further because your angle of depression is together with the horizontal plane. So you have this angle and this angle. So your this one should be 40 degrees. This one should be 30 degrees. Sorry, 35 degrees. Hence, it's 35 degrees one is A and 40 degrees one. Hence, this should be B and this should be A. Okay, so do take note of this. So once you have this, again, this is a right angle triangle. They are asking you for, or you're also given that APB. APB is 55 degrees. So you're given that this is 55 degrees. It's another color. Yep. APB. Okay, so again, we don't really need this information because actually if you use the properties you have learned so far, this part here is a right angle. So fif if you minus 90 minus 35 degrees, you should get 55 degrees yourself. So even if they don't give you angle APB, you should still be able to solve this question. So your first step is, let's say this point is X. You should look at it as two different right angle triangles. So you have angle APB, or sorry, APX, given as this 55 degrees. And then your second right angle triangle, you have BPX. Again, this is 80 degrees. And for this angle, it should be 90 minus 40, so it's 50 degrees. Okay. So how you're gonna solve this is you should just use your Trigo to find your BX and AX, and then minus off the distance to get your distance between A and B. Okay. So let's do tangent. So you get AX is equals to 114.25 meters and BX to be 95.34 meters. So therefore, distance between A and B equals to 114.25 minus 95.34. And your answer is 18.9 meters 3SF. Okay. So this is your this sums up your Trigo for applications of Trigo. So I'll do a quick summary of what we have learned so far. So you should be familiar with your concepts of angle of elevation and depression. Okay. So for this concept, always note that you should look at it vertical plane is the angle formed between the vertical plane and the line of sight. And then the next concept we have learned is bearings. Okay. So for bearings, whenever they say from A, okay, so if it's point A, then your north pole is at point A. And the last concept we have learned is your um, three-dimensional problems. So for this, I can't emphasize enough, but please do draw your diagrams down. So draw it out. So it should form a nice right angle triangle, and then you can use Pythagoras or Trigo to solve this. And if it's not a nice triangle, so normally for bearings, it won't be a nice right angle triangle. So in that case, you can use your sine or cosine rule. Okay. So that marks the end of this chapter. We are going to do more practice for this chapter during our lesson. It's a very crucial chapter. So if you do have any questions, do ask me during our lesson session. Okay, thank you for watching.